We're going to talk a little bit about some enhanced networking features that AWS offers. And generally, the use cases for these are high performance computing, where you have a lot of data or a lot of very powerful computing resources that need to communicate at a high rate of speed. And specifically, AWS offers some specialized network interfaces or virtualized network interfaces that use some special techniques and special processes to enable way higher performance than traditional virtualized network interfaces. To make use of these, you may have to install some additional drivers if you're not using Amazon Linux AMIs. And there's two main ones here, is the Intel 82599 virtual interface that tops out at 10 gigabits and the Amazon Elastic Network Adapter that tops out at 25 gigabits. And which interface you can use depends on which instance type you have. Now, you probably won't be asked on the exam which instance types use which network adapters, but just beware there are two variants out there. I wanted to introduce you to a concept that's relevant for the networking chapter, and that's called placement groups. The idea behind placement groups is we have some control over how we can arrange our instances over the physical hardware that they live on. And AWS has three different types of placement groups. The first being clustered, we have spread, and we also have partition placement groups. And I'll go over each one of these and tell you a little bit about the pros and cons. Now, when we're talking about clustered placement groups, we're talking about grouping your instances close together, generally on the same rack or the same hardware, so that they can have the lowest latency between their communication. Now, in contrast with spread placement groups, we can put our instances on physically separate hardware. So if we're concerned that if a rack fails or a piece of hardware fails on that rack, then it doesn't necessarily take down our whole system because we have some diversity on where that instance lives. Now, a relatively new placement group that's been released is something called partition placement groups. And we'll see some examples of how this differs from a spread placement group in a little bit. But for now, you have the ability to group your instances and then spread those instance groups across different collections of hardware. Now, when might I use a clustered group? Well, if I have applications that really benefit from very low latency communicating between the instances, then I probably want to use a clustered placement group. Now, in contrast with spread placement groups, let's say that I don't necessarily want to have all my instances on the same physical hardware rack in case that rack has a problem. So I can spread my instances across different physical racks. And for partition placement groups, if I have a really large application that consists of a lot of instances, then I can group those different layers and different partitions and manage how those partitions are spread across different hardware. Now, the benefit of a clustered placement group is that we can benefit from some enhanced networking throughput and a very low latency. The downside is that clustered placement groups have a finite capacity. There's only so much that you're going to be able to jam onto one physical rack. So it's generally recommended that if you're going to make use of a clustered placement group, go ahead and provision all the instances that you need up front, because it may be very difficult to add an instance to that clustered placement group later down the road because maybe there's no capacity. Now, the benefit of a spread placement group is that I can put my instances across multiple AZs, and the spread placement group is going to be sure to enforce that for me. The downside is that I can only have a maximum of 7 instances running per group per AZ. Now, as far as partition placement groups, the benefit there is it's really designed for large multi-instance architectures, and we'll see an example of this in a bit. But as you'll see in a bit too, it doesn't support dedicated hosts. And you think that kind of makes sense because if you're putting everything on a dedicated host, well, generally, then you're just a clustered placement group. And that makes sense if you think about it, because if you're just putting everything on a dedicated host, you might as well be using a clustered placement group. So let's look at some visual examples. I think that may help reinforce some of these concepts. So by default, AWS will just allocate space for your virtual instances on whatever rack and whatever physical machine it can use. It tries to spread this equally. And let's say that maybe you have an application that you want those instances to be very close together. And so you would use a clustered placement group. In this example, we have VMs 1, 2, and 3 that all happen to be on the same rack. Let's say we are concerned about a physical machine failing or maybe a rack failing. We would use a spread placement group to get some diversity on what systems are actually hosting our VMs. Now, partition placement groups are sort of the evolution of spread placement groups. Let's say you have a pretty large distributed application that has maybe 50 underlying instances. By using a spread placement group, each instance would be theoretically placed on its own set of unique hardware. And this gets really kind of crazy if we're thinking about, maybe 100 or 500 instances out there. And so rather, we can group instances into logical partitions and have those placed on separate racks. And we still have the resiliency because our application inherently can deal with those nodes going offline, but we still have the benefit of hardware diversity. And so, for example, in our distributed application, in this case, it's a Hadoop HDFS landscape, we can tolerate having VMs go offline. That particular landscape is tolerant of machines coming in and out. But we also, by using partition placement groups, we are able to still have some benefit of hardware diversity.